Before studying the energy band, let us study how the different substances. Okay, let us take gaseous substance, liquid, and solids. So in gaseous, so the molecules are spread apart like this. So in gaseous substances, the molecules are spread apart and they are not close to each other. So this is the arrangement of molecules in a gaseous substances. So let us consider liquid. Let us consider the liquid substance. So in liquid, the molecules are closer to each other like this. The molecules are closer to each other. In solids, the molecules are closely arranged together. All the molecules are closely arranged together like this. Let us fill it. Okay, so but in solids the molecules are closely arranged together. Due to this, atoms of the molecules, they tend to move into the orbits of the neighboring atoms. Okay, so from this diagram you can understand, in gaseous state molecules are widely spread and they move freely. There is no fixed shape and volume for the gaseous substances. There is no fixed shape and there is no fixed volume. Very little interaction between the molecules. In liquid state, the molecules are close together than in gaseous substances, but not tightly packed like in solids. They are close, they are not tightly packed, but they can move fast each other. These molecules can move fast each other. Because of this, it gives liquids a fixed volume and not a shape. So no fixed volume but not fixed shape. Here there is no fixed shape and there is no fixed volume. No fixed volume and no fixed shape in a gaseous substances. But in solids, the molecules are closely packed in a regular pattern. So this close packing causes electron orbits. Show you. Electron orbits. This close packing causes electron orbits of the atoms. They overlap and which leads to the formation of energy band. So this is the formation of energy band. So the right side of your figure, this is the energy band in a solids. When atoms come very close in a solid, their atomic orbits means energy levels, they interact and split into many closely spaced levels. These split energy levels, they group together and to form what we call as a energy band. So based on this, there is a valency band and conduction band. The lower band usually filled with electrons, this is called as valency band, and the higher band where the electrons move freely and they conduct electricity, that is conduction band. And there is a band gap the energy difference between the valency band and the conduction band. So this is about the arrangement of molecules in different substances. The energy band of an atom, it is a concept. So in conduction band, conduction band is higher in energy than the valency band. So compared to the valency band, the conduction band has higher energy compared to the valency band. Okay. The electrons in this band are free to move. The electrons in this band are free to move. So, and they conduct electricity. This is about conduction band. Then there is a energy gap between valency band and the conduction band. This is called as a band gap. This is called as band gap. The energy gap between the valency band and the conduction band. Materials with larger band gap, they are insulators. Small band gap, they are semiconductors. No band gap at all, overlapping bands, they indicate conductors. So this is about the band gap, valency band and a conduction band. Let us write the difference between insulator, conductor, semiconductor and conductor. So in insulator, the band gap between the conduction band and valency band, it is more than 3 electron volt. Electron volt is the unit of band gap. So it is more than 3 electron volt. The distance between the two bands is very, very large. In semiconductor, there is a small gap. So there is small band gap, that is approximately 1 electron volt. So this is about 1 electron volt. And in conductor, there is no gap at all. So they both overlap each other. Conduction band and valency band, they overlap each other. There is no gap or the bands overlap. So this is the first difference. So the valency band and the conduction band, they are very far apart because the band gap is very large. So both valency band and conduction band are far apart. In semiconductor, because the band gap is very less, approximately 1 electron volt, they are close together. And since they are overlapping each other, the conduction band and valency band, there is no band gap energy, there is no band gap, so they overlap each other. Next, electron movement. So in insulator, the electron movement is very, very difficult because the electron from the valency band, they cannot go to the conduction band for the conductivity. So the electron movement is very difficult because of large energy gap. So in semiconductor, it is possible with help of some energy. So either heat energy or light energy, if we give to the electron can go from valency band to the conduction band. And in solid, it is very easy for the movement of the electron because there is no energy gap. And conductivity is the next parameter. The conductivity in insulator is a very poor. That's why they are called as bad conductors. Semiconductor, it is moderate because with the help of energy, external energy, it can be controlled. So it is conductivity is moderate. Conductivity is very high in conductors because it does not require external light energy or a heat energy. Examples for insulator: rubber, glass and plastic. Examples for semiconductors: silicon and germanium. Examples for conductors: copper, silver, aluminium. And what is the use of these materials? So insulators are used for insulation, semiconductors are used for electronic solar cells, and conductors are used in wires and circuits. Let us recall all the points. In insulator, the valency band is full, conduction band is all empty, completely empty, and the band gap is very large, more than 3 electron volt, and conductivity is very, very poor. And the examples for insulators are rubber, glass, and plastic. In semiconductor, the valency band is almost full, the conduction band is almost empty, and the band gap is very small, approximately 1 electron volt, and the conductivity is moderate and it can be improved. Examples are silicon and germanium. In conductor, the valency band overlap with the conduction band, and the conduction band contains free electrons and there is no gap or they are overlapping each other. The conductivity is very, very high, and the examples are copper, silver, and gold. So the valency band, the electrons in the outermost shell are known as valence electrons. These electrons contain a series of energy levels and they form energy band. They are known as valency band. The valency band has the highest occupied energy. Conduction band, the valence electrons are not tightly held to the nucleus, due to which few of these valence electrons leave the outermost orbit even at room temperature and they become free electron. The free electrons conduct current in conductors and therefore they are known as conduction electrons. The conduction band is the one, it contains conduction of electrons and it has lowest occupied energy level. Then there is a energy gap, it is called as forbidden energy gap. The gap between valency band and a conduction band, it is referred as forbidden energy gap. As the name suggests, the forbidden gap does not have any energy and no electrons stay in this band. Very, very important point. No electrons will stay in this band. There is a gap, that's it. It does not have any energy. It is like electron in the first floor and electron in the second floor. Electrons should stay in either first floor or a second floor. So it will not stay between the two floors like that. So you can compare. As the name suggests, the forbidden gap does not have any energy. No electrons stay in this band. So if the forbidden energy gap is greater, then the valency band electrons are tightly bound and they are firmly attached to the nucleus. So we require some amount of external energy that is equal to forbidden energy gap to move from valency band to the conduction band. So this is all about the energy band in 3 different substances. In this atomic structure, the electrons in the outermost orbit, this will be having first energy level. This is first energy level. So in the second, this is having second energy level, and this will be having third energy level, and this is our nucleus. This is our nucleus. So always the outermost orbit has the highest energy level.